Aloha, I'm Chris Brenchley, meteorologist in charge of the National Weather Service Forecast Office, Honolulu, and the Central Pacific Hurricane Center. Skywarn spotters are very important to us. Their reports are necessary for us to identify and verify critical weather events. As a Skywarn spotter, you will be our eyes in the field identifying potentially hazardous weather. We understand that some people cannot attend our Skywarn spotter training sessions in person, so we put together this online training video that you can complete from your home or anywhere you can access the internet. Upon completion, you will become a certified Skywarn spotter. After you are trained to be a spotter, you can also complete your refresher training when needed so you can stay certified. This video allows us to widen our network of certified Skywarn spotters and keep us better notified of important weather events. Mahalo for taking the time to watch this training video and for becoming a part of our team.
Aloha, I'm John Bravender, the Warning Coordination Meteorologist for the National Weather Service Forecast Office in Honolulu and the Central Pacific Hurricane Center. In Hawaii, we usually have nice weather, but that's not always the case. There are times where we have weather events that can be dangerous to people and damaging to property. We want to make sure we are providing the public with the best weather information possible at all times. To do this, we have top-of-the-line equipment, expertly trained personnel to help us develop the best possible forecast. But there are still times where we cannot see everything. This is where you can be involved. You can have a dramatic impact on the accuracy of our weather products to help ensure residents are informed with the most timely and crucial weather information needed to protect life and property. To do this, you need to learn a few things first. A professional meteorologist from the Weather Service is going to take you through the process of becoming an effectively trained Skywarn spotter. That way, you will always know how, when, and where to safely report the latest weather events that could potentially impact lives, from tornadoes and waterspouts to hurricanes, lightning, and flooding. Whatever the weather phenomenon, we want to make sure you have the proper tools to accurately identify dangerous or hazardous weather conditions so that residents know which areas to avoid and emergency personnel know which areas to focus their resources on. Mahalo for taking the time to becoming a trained Skywarn spotter. You will truly be helping us accomplish our mission of becoming a weather-ready nation.
Aloha, I'm Chevy, meteorologist at the National Weather Service Forecast Office in Honolulu, co-located with the Central Pacific Hurricane Center. Today we're talking about spotter training, and I'm going to be your trainer. We're going to go through many slides, and it's going to take quite a bit of time, so make sure you're relaxed, grab yourself a snack, and anytime you need to pause, of course, you can. Take a look at the National Weather Service. Here's a picture of our office on the UH Manoa campus. We are part of NOAA, the National Oceanic and Atmospheric Administration. Basically, that's everything in the atmosphere and everything in the ocean. Of course, we take care of the part that's in the atmosphere. And NOAA falls under the Department of Commerce. Well, how many offices do we have across the country? Over 120. And that includes offices such as the National Hurricane Center in Miami and one of our offices, the Central Pacific Hurricane Center.
In our office, we have a total of 29 meteorologists, which include 4 managers, 1 senior hydrologist, 5 senior forecasters, and 19 journeyman forecasters. We also have 1 operational programs leader, which is in charge of the co-op program, 2 electronic technicians that keep everything working around the office, 4 people from IT that support staff, and 1 administrative assistant. At the National Weather Service Honolulu Forecast Office, we forecast the weather for the state of Hawaii, which includes watches and warnings. We give forecasts for airports and aviation routes across the Pacific. We also forecast winds and waves for ships at sea and around coastal waters. During the hurricane season, we forecast hurricanes in the Central Pacific Basin, and throughout the year, we do a lot of data gathering, quality control of data, and climatology. To send out a good forecast, we use various tools to help us. We use our computer-generated weather models, such as the GFS and the European model, to look at different levels of the atmosphere through time. Radar and satellite images are also very important to us, so we know what is happening in real time. We also use different kinds of observational data from weather stations across the islands and the airports to monitor wind and rain. In Lihue and Hilo, we send out weather balloons twice a day to get an atmospheric profile so the forecasters can analyze, create, and improve their forecasts. The radars are very important for day-to-day weather and become especially important when severe thunderstorms or hurricanes are in the area. The radar allows for forecasters to see the eye of the storm of a hurricane and the incoming rain bands that are associated with a big storm. The red dots on this graphic depict the locations of our 4 radars. They are located in Lihue, on Molokai, and 2 on the Big Island, 1 at North Kohala and 1 in South Point. The white circles are the radar coverage zones for each radar. Notice how we have overlaps in coverage to help us with redundancy in case one of the radars are inoperable. Who do we work with? At the National Weather Service, we work with emergency managers across the state, including Civil Defense, the Department of Defense, to ensure the public's safety. We also work with fire departments and police stations. We have a great working relationship with the media, such as Hawaii News Now, KHON, and KITV. They use our weather products in their on-air weather presentations. We also work with the Department of Education regarding outreach activities in schools. Back to the weather. So this course will take you on a Weather 101 that will be the basic weather in Hawaii and what to report when you are out and observing the weather. Let's look at the big picture in the Northern Hemisphere. Weather is produced by high and low pressure. High pressure to our northeast is usually associated with good trade wind weather in Hawaii. On the other hand, low pressure is known to be more unstable and associated with bad weather, such as heavy rains, thunderstorms, and hurricanes. So when we plot the low and high pressures on the surface analysis, you can see how different weather features are formed because of the pressure. Here we have low pressure that's associated with a cold front. There's also a stationary front, and we have surface highs as well that are associated with stable weather. As you can see over New England on this surface analysis chart, the tight pressure gradient is associated with the high wind speeds. The closer the lines are together, the higher the wind speeds are expected. That's called a tight pressure gradient. Here are a few basic definitions of what climate is versus the weather. Your climate is the weather conditions prevailing in an area in general over a long period of time. When we look at the average sea surface temperatures over the last 30 years, that is an example of climate. Weather, on the other hand, is the state of the atmosphere at a certain place in time. For example, heat, dryness, sunshine, wind, or rain are all examples of weather. Another example of weather is a forecast if it is going to rain tomorrow in Honolulu, or a flood that is happening right now in Maui. Here's another basic definition of instability. The condition in the lower atmosphere, which is generally considered to be unstable, and as a result the weather is subjected to a high degree of variability through distance and time. When we think of instability, it is when there is a lot of lift in the atmosphere, which can lead to strong precipitation events across the islands. And a lifting mechanism is anything that causes lift in the atmosphere, such as a cold front or even the mountains. Ko'olau mountain range, for example, acts as an elevator for the moisture to travel vertically. We will be going over a few of our weather patterns that we have in Hawaii. Trade wind weather is what we have for the majority of the year. We also have convective weather, weather that's enhanced from a daytime sea breeze when the wind is moving onshore with upslope flow, or at night when the land breezes go offshore and back down the terrain. Third is an upper level low or a trough that brings a lot of rain as well as a cold front or shear line. One of the big storms we receive in Hawaii in the wintertime is known as a kona low, or throughout the summer and fall we can receive tropical cyclones. The first weather pattern we will be going over is the trade wind pattern that affects the Hawaiian Islands a majority of the time. High pressure rotates clockwise around the high that sends winds out of the northeast. These northeast winds are known as the trade winds. The trade winds are driven by the subtropical high and is the most dominant feature affecting Hawaii. As I mentioned earlier, the trade winds are in place around 75% of the year. About 90% in July and about 50% in January when the winter storms such as upper level lows or cold fronts come through that will break down the trade winds during that period. When we look at a graph of the frequency of the trade winds, we can see that there are more dominant trade winds from May through September, where in our winter months they are a little less frequent. Although the most common weather pattern is the northeast trade wind flow, there has to be local considerations as the topography of each island determines where the wind and rain patterns fall. 50% of the land in the Hawaiian chain is actually above 2,000 feet. Mauna Kea and Mauna Loa on the Big Island are near 14,000 feet. Haleakala on Maui is about 10,000 feet. And these volcanoes can affect the winds. These high elevations play a role in where the trade winds can flow when they go around or move about the mountains. You can see in this picture how winds interact with the terrain on Maui. The trade wind direction wind stream lines over Maui show how the topography funnels and moves the wind around the island. As we can see between the West Maui Mountains and Haleakala, the winds funnel through the middle. Some of that wind actually will go through the middle of the mountains, and some may turn southwest and on the shore on the west side of the islands as some eddies may form. When we think about the local considerations of the terrain, this also leads to different areas of where we would receive rain on a typical day. This is known on the islands as orographic precipitation, in which the trade winds move the air onshore and the mountains provide the lift as the air cools as it's lifted. The air then becomes saturated and condensed to water droplets to form clouds. These showers favor the windward sides of all of the Hawaiian Islands due to this lifting mechanism. In the next few slides, I will show you where the average rain falls. Based on what you've learned on the last few slides, we would expect that the windward side should have more rain than the leeward side over an annual period of time. The average rainfall island maps show the mean annual rainfall for each island. As you can see that Oahu has the most rain on the windward side. Kauai has the most rain in the highest elevations, where Mount Waialeale is located. This area is known to be one of the wettest spots on Earth. The leeward sides of each island end up with very little rainfall. The same can be said with the Maui County and the Big Island rainfall maps. As you can see, more rain occurs on the windward side and at the higher elevations. By the way, as you look at this rainfall data, is this an example of weather or climate? These graphics represent a good example of climate.
The trade winds can be seen here in this visible satellite image. The wind is coming from the northeast, therefore creating clouds on the windward side and higher elevations of every island. New technologies such as the newest GOES-17 satellite has produced high-resolution imagery for us to improve our weather forecasting. In a wet trade wind environment, we see a lot of cloud buildups on the windward side, but also some of them spilling over to the leeward side when direction is the same from the northeast. A rain shadow develops on the leeward side of the islands after the moisture comes down the windward side. Strong trade winds produce more clouds and showers over the mountains and onto some of the leeward side. This causes the rain to be more uniform. The stronger trade winds are produced by tighter pressure gradient to our northeast. Next are the convective weather patterns here in Hawaii. Some of this may be focused on the leeward Big Island and Haleakala on Maui. Some locations vary depending on the direction and wind speed that occurs on all islands when trade winds are weakened. One example of the trade winds weakening is when there is a sea breeze where air travels onshore up the mountain and the lift provides the elevation gain and convergence over the land. The higher moisture content in the air results in more shower coverage. In conjunction with a low pressure system or trough above Hawaii, the showers may intensify or may even grow into thunderstorms. When we have a sea breeze, clouds will build up most of the mountainside. Looking at the satellite at a local time of 2:30 p.m. Hawaiian Standard Time, and with a prevailing wind direction from the northeast, it sets up a high and low pressure on the Kona coast. The wind offshore of Kona goes back toward the land. This creates a sea breeze effect on the Kona coast that may bring up afternoon clouds and showers in that area. On one hand, we have the sea breeze, but also we have the land breeze. In a land breeze situation, winds travel down the mountains and out to the sea. Sinking air suppresses clouds and showers over the islands. This leads to very little rain on the land, and a land breeze is associated with mostly clear weather overnight and early morning time periods. Simply put, the clouds will build up off the coast, not on the land. Another weather pattern is the upper trough or low pressure. The relatively cool pool of air aloft will erode the trade wind version and reverses sinking motion over Hawaii and allows for rising motion. At the office, when we want to look at upper level features, the water vapor image is effective during these weather patterns. The upper trough may enhance the low level weather features. The strength of the trough will dictate how much influence it will have. The stronger troughs or lows are more likely to produce heavy rain, thunderstorms, or reduced visibility. Thunderstorms are active lightning producers. As a Skywarn spotter, it is key if you do see lightning associated with the storm. It would be awesome to report what you saw. This is a map of the amount of thunderstorms we see around the United States. As you can see, on the Hawaiian Islands, it is very unlikely to get a lot of thunderstorms compared to the southeast part of the continental United States. Another weather feature are the cold fronts that come through the islands. Typically a 1 to 3 day event in which can be associated with bad weather or wind shift and a temperature drop. Most cold fronts are generally weak upon reaching Hawaii. Those strong fronts can be significant weather producers. The fronts often slow and weaken when near the islands. The trailing end of the frontal band is known as a shear line and can remain intact, producing rain for several days. When we see a cold front on the satellite imagery, it is shown as a long band from the north and comes down to the islands. Cold fronts are typically more common from October through March. Here is another example on the visible imagery on when the front is near the islands. You can see the tail end of the cold front above Kauai during this time period. When we have a cold front that comes to the island, sometimes a cold front may not make it all the way down the island chain. Here is a graphic of the annual cold frontal passage frequency for each main island. Kauai has an average of 16, Oahu an average of 14, Maui 11, and the Big Island 9. Cold fronts come from the northwest, which is why Kauai has more cold fronts compared to the Big Island. Simply put, the farther north you are, the better chance you have of cold frontal passage. When looking at a cold front, the winds may shift to Kona wind, which is a southeast flow. One of the big weather events is the upper level low known as the Kona low. Deep tropical moisture from the ITCZ near the equator produce these weather makers. Kona lows are associated with moderate to strong winds, with even stronger winds at the summits and higher elevations. These are very efficient rain producers that can be widespread areas of 2 to 4 inches with rain totals upwards of 8 to 12 inches near the mountains. Record amounts of rainfall as high as 54 inches in a 3-day period or 25 inches in 24 hours can be associated with this weather phenomena. In 2006, the 40 straight days of rain on Oahu, some of the days were associated with the Kona low. The reason why we are sharing with you these weather events such as Kona low is because they are associated with thunderstorms that can be severe, produce a lot of rain, and even produce flooding. Climatologically speaking, the North Pacific has about 3 to 4 of these storms per year. They are known to have erratic motion with a tendency to move slowly westward. The struggles of these events is that they are hard to predict the movement and strength. They can also last long, even more than a week.
Tropical cyclones are one of the most potentially damaging for the Hawaiian Islands. On average, there are about 4 to 5 tropical cyclones annually in the Central Pacific Basin. The direct hits to Hawaii are rare, but they are devastating. A few examples of this were Hurricane Dot in 1959, Hurricane Eva in 1982, and of course, Hurricane Aniki in 1992 on Kauai. The Central Pacific hurricane season begins on June 1st of every year and ends on November 30th. About 1/3 of storms actually reach hurricane strength. The primary factors are sea surface temperatures and the lack of shear. Recently, in the last few years, storms have come close to our coastal waters, with Tropical Storm Olivia making landfall on Maui County twice. We will go over a few examples of hurricanes in the next few slides. When we look at tropical cyclones in the Central Pacific by month, some months have a lot more tropical cyclones than others. Hurricane season is the most active in July through September, with August being the peak month. Zooming out more and looking at the years now, we see that tropical cyclones can vary greatly year by year. During an El Niño season, when sea surface temperatures are warmer than normal, it is associated with more tropical cyclones, versus a La Niña year when sea surface temperatures are cooler than normal. Tropical cyclones in La Niña years have less hurricane activity. The hurricane season of 2015 had a strong El Niño. In the summer of 2015, the sea surface temperatures were above average, well above average. We had the record Central Pacific tropical cyclone season. While there were no direct hits to any of the islands, we had many indirect effects from high surf and rain associated with a few of the tropical cyclones. Simply put, a tropical cyclone doesn't have to make landfall to affect the islands. The cutoff from the subtropical high, no trade winds, and thermal-driven sea breezes kept the warm, moist air mass stationary over Hawaii. When tropical cyclones come through, it takes away the typical summertime upper trough over Hawaii. A very cool graphic created by our senior hydrologists in the office. For each of the 15 cyclones we had in the 2015 season, a daily image was extracted and superimposed on the map. It shows how lucky we were that the storms came close to the islands but didn't make any direct hits. The hurricane season of 2016 had a rapid springtime transition from 2015 El Niño to a weak La Niña condition by the end of the season. As you can see on the figure, we did have Tropical Cyclone Darby that entered our coastal waters that brought some flooding to the islands. Moving along to hurricane season 2017, it started with equatorial warming in the spring, but it never transitioned into El Niño. It was a non-active season with just one storm entering into the Central Pacific Basin. With the steady cooling commenced during the summer, it led to La Niña conditions by the end of the season. This resulted in below normal tropical cyclone activity. The hurricane season of 2018, we had Skywarn spotters on all the islands, and they were very helpful issuing flood warnings to protect life and property. Hurricane Lane brought a huge amount of rain, upwards of 60 inches on the windward side of the Big Island during Lane's 5-day duration. Numerous Skywarn spotters reported on integral weather events over those 5 days. Tropical Storm Olivia also provided rain across the islands. Tropical cyclone genesis is shown. That is the beginning of tropical cyclones. So you guys need to be aware where they're from. Most of the tropical cyclones that enter the Central Pacific Basin come from the Eastern Pacific off the coast of California and Mexico. As you can see from the past hurricane season and from future seasons, tropical cyclones have a big impact to the land in the form of storm surge, wind, and intense rainfall that produces flooding. Storm surge is one of the most dangerous variables, especially near the coast. The wind, even at tropical storm strength, has potential to be very damaging to lives and property. Intense rainfall and flooding is also a huge impact that you as a spotter can have to our operations.
During severe weather, we need to warn people and get the message to the public as soon as possible. We send out numerous amounts of different types of watches and warnings. That includes flash floods, tornadoes, hurricanes, and tsunami watches and warnings. The message is sent out through mobile phones, TV, radio, NOAA weather radios, and our website. Social media has been gaining traction, so we are also posting to different social media platforms so you can be informed with our latest watches and warnings. So when we issue these watches and warnings, they are based on what we see in observations or if one of the weather spotters are calling to report something. Here is our website link that you can go to for all of our products, weather.gov/HFO. Let's go over a few basic definitions regarding clouds. The anvil is the large, relatively flat portion of the thunderstorm located at the very upper reaches. As the updraft from the cloud still has momentum, there becomes an overshooting top. When you see a big storm cloud, it is the dome-like bubble of cloud material extending above the anvil. Below the anvil is the storm tower. The storm tower is the main body of the storm that contains the updraft that produces the towering clouds. Here is the picture of what the basic definitions are and how they look. These are the keys to what we are looking for. Another set of basic definitions is the rain-free cloud base. This is the low, flat cloud base with little visible precipitation following and updraft towers above. And a wall cloud is the isolated lower part of a rain-free cloud base. And here's the storm structure photo of what you would call these definitions above. The third basic definition set is the severe thunderstorm and the funnel cloud. The severe thunderstorms are storms that produce a sustained wind of 58 miles per hour or greater and or hail greater than 1 inch. A funnel cloud is a rotating funnel-shaped cloud extending from a thunderstorm base, but the difference between a funnel cloud and a tornado or waterspout is it is not touching the ground. This is a photo of the funnel cloud event from Haleiwa in 2013, and also one in December of 2008 in central Maui. When calling in a report of a funnel cloud, look for persistence, and also if the feature is attached to a storm cloud or is it in contact with the ground or water. Another basic definition you should know is a Skywarn Spotter, the waterspouts and shelf cloud. A waterspout is a violently rotating column of air pennant from a storm cloud over the water. And the shelf cloud is a broad, flat cloud stretching out ahead of the main storm that forms along a storm's outflow. And here is the waterspout photo. These were taken here in Hawaii on the south shore of Oahu in 2011. The funnel cloud reached the water and became a waterspout. This is a photo example of a shelf cloud. The shelf cloud, you can see the broad, flat cloud stretching out ahead of the main storm. Another set of basic definitions are the tornadoes and downbursts. A tornado is a violently rotating column of air independent from a thunderstorm and in contact with the ground. Once a funnel cloud touches land, it becomes a tornado. A downburst is also known as a microburst. It is a strong downburst with an outrush of damaging wind on or near the ground. Sometimes locally we have reports of damaged roofs that are associated with microbursts. And this is a visualized photo of a downburst where you see the rush of damaging winds that were near the ground. These are tornado photos that happen locally on Kauai and Oahu. Although tornadoes are a rare occurrence, they do happen in Hawaii, and you are our eyes in the field that can report these severe weather events. As a Skywarn spotter, it is important to see some of these upper-level storm clues. These can be an overshooting top and have anvil characteristics. The overshooting top looks like a dome, a bubble of cloud material extending above the anvil and persisting for greater than 10 minutes. These anvil characteristics are thick, cumuliform, with sharp, well-defined edges, as we will show you in the next slide visually. These are examples of overshooting tops in an anvil. As you can see, the overshooting top is a dome that shoots up past the cloud.
and the anvil on the right side of the photo that was created with a large amount of instability. These upper-level clues are precursors to events such as a tornado. Simply put, the rotating wall cloud and funnel cloud may lead to a tornado. This is a photo of a funnel cloud. In the middle area of the photo, you can see the cloud starting to rotate. Likewise, in this slide, where do you see the funnel cloud? It's right here, on the top left, where the rotating cloud is. If you spot this, it is very, very important to let us know. Tornadoes do have a few look-alikes, such as gustnados or dust devils. A gustnado is a surface-based circulation that initiates along thunderstorm outflow boundaries. Usually the gustnado is associated with the storm and will likely be out ahead of the main storm. On the next slide, we will show you what a gustnado looks like that happened on the Big Island. The dust devil is another tornado look-alike and has surface-based circulation that may or may not occur in the vicinity of the storms. There could be a possibility of a connection with a storm. The dust devil circulation can be drawn upwards into a storm, becoming a tornado. Here are some non-tornadic threats that could happen in Hawaii. These are events known as a downburst and hail. We talked about the downburst earlier in the video. Now we talk about the threats a downburst can impose. Damaging winds produced within a thunderstorm can exceed 100 miles per hour. These downbursts are skinny as wind swath are less than 2.5 miles wide. Also, hail are chunks of ice formed within a storm due to intense updrafts. The largest hailstone found has been over 11 inches in diameter. Imagine that. Overall, microbursts are bursts of cloud precipitation descending from the thunderstorms. The rainfoot indicates winds descending to the surface, then spreading out laterally. It is important to report microbursts quickly, as they are very difficult to forecast and warn for and to see on radar. For hail formation, it is important to have the intense updraft. As the ice moves vertically with the very cold temperatures aloft, the hail is too light to fall through updraft and the large hail falls out. On the windward side of Oahu in 2012, hail of 4 inches was found in an intense thunderstorm. When reporting hail, when possible, measure the hail diameter with a ruler. When describing hail, use common objects like pennies, nickels, quarters, golf balls, baseballs, etc. Do not use marbles to explain. I will explain to you why on the next slide. Always report the largest hail that has fallen in your area. The reason why when reporting hail we don't use marbles is because marbles can be all different sizes with no distinct size like coins, a golf ball, or a baseball. Being aware of all these different weather phenomena that you are reporting is very helpful to us. But your safety is of utmost importance when you are being a spotter. In the next few slides, we will be going over the safety tips in different weather events. ACES. It's the Skywarn Safety acronym, ACES. A stands for awareness, to be aware of where you are and to judge if you need to move or stay where you are because you are safe. C stands for communication, being able to communicate with others around you to be safe. E stands for escape routes. If you're in the situation that's dangerous, you need to have an emergency route to evacuate. S is for safety zones that you know of that will keep you safe and where you feel protected. Remember ACES so you can remain safe in any situation, including spotting.
When you talk about weather hazards across the state of Hawaii, definitely way up on the list is flooding, especially flash flooding, flooding that occurs rather quickly. So remember, anytime you're near a stream or a river, you can be inundated with water rather quickly. Let's take a look at this video, where a few tourists got into a situation where the water just became unbearable and they couldn't deal with it. So when you go out and about, what you want to make sure of is that you check with our forecast, you know exactly what the weather situation is, know exactly what you're getting into before you go outdoors. You don't want to get into a situation where you're in trouble with a lot of water running downstream. Tornado safety is very important because of the dangers that tornadoes present to us, of course. If you are near buildings or homes, seek shelter in the lowest place possible, preferably in a sturdy structure. If you are outside, lie flat on the ground or in a ditch. But watch out, if you go in a ditch, be careful that it's not flooding with water. When you are inside, go to the basement or room in the center of the structure or a building with no windows. If you are in a rural location, drive away from the tornado. If you are in an urban area, do not attempt to drive. Your number one priority should be to seek shelter. When it comes to lightning safety, no place outside is technically safe if there is lightning nearby. It is important to move indoors or into a metal top vehicle with the windows up. Try to stay off the phone or other electronics. Also stay away from plumbing, metal fixtures, windows, and doors. Do not lean or lie on concrete or walls. If you are caught outside with no safe shelter nearby, these tips may reduce the risk of getting struck by lightning. Immediately get off elevated areas such as hills, mountain ridges, or peaks. Get to low ground such as a valley or a ravine. These are things not to do in this situation. Never lie flat on the ground. Never shelter under an isolated tree. Never use a cliff, a cave entrance, or rocky overhang for shelter. To get out and away from water, and also stay away from metal such as barbed wire fences and power lines. These are the things you need to concentrate on. Flood safety is an important topic, especially in Hawaii. Never drive across the flooded road. If a car stalls in the water, leave the vehicle and seek higher ground immediately. Avoid low-lying areas. And remember that water can rise rapidly, and the current is stronger than you think. When flooded, turn around, don't drown.
Let's talk about safety. We want to make sure that as you work as a spotter for us, that you are safe at all times. Remember, safety is number one, okay? Make sure you are safe before you attempt to get any kind of spotter reports for the National Weather Service. So let's take a look at this video and see what's wrong with this. This guy violated the number one rule. Turn around, don't drown. Never, ever drive across water-covered roads. It can only lead to bad things. Fortunately, the bus driver and the kid that was aboard are safe, but it's just a reminder, nothing good happens when you drive across a flooded road.
Here are a few tips on hail safety. Get inside a sturdy structure. The cars will be sufficient protection against hail until hail reaches golf ball size. During hurricane season, here are a few tips on hurricane safety. Prepare your home ahead of time. Know where to go. Shelter at home, shelter to friends or relatives. Hurricane evacuation shelter is also an option, depending on your home's ability to withstand a hurricane. Put together a go bag, disaster supply kit, including flashlight, batteries, cash, first aid supplies, medications, and copies of your critical information if you need to evacuate. If you are home, plan for adequate supplies in case you lose power and water for several days and you are not able to leave due to flooding or blocked roads. Make a family emergency communication plan. And most importantly, listen to local radio, TV stations if you can, the NOAA weather radio if you have one, or if you can log online, you can go to hnl.info for Honolulu County information. There are several ways to be informed. We mentioned hnl.info for Honolulu County areas. You can also log on to our website. If you forget what the address is, just Google NWS Hawaii and it'll be the first one you find. We also have social media outlets with daily posts you can check out. NOAA Weather Radio and the website are great ways to check out what's going on. The weather radio repeats your forecast and tells you about all the watches and warnings, especially in your area. And we update the forecast and watches and warnings, of course, on our website. Your role as a spotter is to relay weather information during hazardous weather events and to provide information to verify weather watches, warnings, and advisories. Also to help generate a historic record of hazardous weather events. So here are some more tips on what to go over and how to report it. We definitely want you reporting
tornadoes, waterspouts, funnel clouds, rotating clouds of any type, and flash flooding. If you're doubting what you see, please call us. We may be able to find out. If possible, snap a picture of it. We may be able to determine if it's an innocent-looking cloud or maybe a dangerous tornado. Please take a picture if you can and send it to us. If the winds are greater than 50 miles per hour, if the hail is greater than a half an inch, please report that. Hail that's any size in Hawaii, as a matter of fact, please report it. Damage of any kind due to the weather is also important. If you are able to recognize and see the storm structure, please report it. Also, if visibility is less than 1 mile or you're experiencing heavy rainfall or any type of snowfall, report it. When you do call, what do you want to say in a report? These numbers are for reporting only, not for getting information. When you call, you want to give your name, your spotter number, your location in case you're not at home, and then you want to include what, where, when, what is going on. Be brief and be concise. We appreciate your calls and being able to be our eyes out in the field. This is an example of a Skywarn Spotter call. NWS. National Weather Service, how can I help you today? Hi, my name is Jason Smith, spotter number 715. I'm calling to report heavy rain at my house in Pearl City. It started about 30 minutes ago, and I see in my rain gauge that I already have 1 inch. Also, there are streams forming on the sides of the streets. Okay, we see some showers above your area on the radar. Thanks for letting us know the rainfall rate, and thank you for your report. When you report it, can be a crucial part to issuing a local storm report pictured here. A trained spotter will give us a report and will help issue these real-time watches and warnings to help our mission of protecting life and property. Another source of sending weather reports is called MPing. You can download it on iOS and Android platforms. MPing is crowdsourcing weather reports that when you report it through the app, we will see it on our workstations. Aside from MPing and being a spotter, we also are looking for people to be a part of what's called the COCORAS. It is a community collaboration for rain, hail, snow reports, a giant network that is across the United States to measure all of these weather phenomena. Another program is called CWOP, or CWOP, the Citizen Weather Observer Program. The Citizen Weather Observer Program is a private-public partnership that allows people with computerized weather stations and always on the internet access to send their weather information to a special data server that collects weather observations from around the country. To those that have renewed your training watching this video, we want to thank you and tell you to please let us know that you've watched this so we can renew your Skywarn certification. For those that are watching this video so you can become a Skywarn spotter, please make sure that you email either myself or Gavin at these email addresses. Thank you for taking the time for this important training, which will help you become a fantastic Skywarn spotter. We are open 24 hours a day, 7 days a week, 365 days a year. So whenever you see severe weather happening, be sure to give us a call so we can get these very important messages to the public as soon as possible. Well, that wasn't so bad, was it? Thank you for bearing with me through all this training today with the weather across the state of Hawaii. So now we need to take care of some administrative things. You need to take a quiz to make sure you've been paying attention through this training session. And you need to get your ID card and your certificate. So, whether you're new to this or you're doing a refresher course, you need to do the refresher or new spotter quiz, and then we'll send you out an ID card and we'll send you out a certificate of completion. All you need to do is give us a call or send us a message at this email address. Once again, mahalo.
Now that you know how to provide us with valuable weather information and be our eyes on the storm, we'll be sending you some information. In the coming weeks, you will receive a Weather Spotter field guide along with a certificate of training and a unique Weather Spotter ID card. You will provide us the number on the card when you are calling in a weather report. That way we will know who you are and that you are a trained Skywarn spotter. Mahalo for completing the training, and be safe out there as you begin your weather adventure with us.
Aloha, I'm Ashley Evans, the Director of Operations for the National Weather Service, Honolulu Forecast Office, and the Central Pacific Hurricane Center. Thank you for taking the time to watch the Skywarn Spotter training video and taking this important step to becoming one of our certified spotters. Once certified, or in some cases recertified, you will become a member of our diverse observer team and be a crucial link to identifying hazardous weather across Hawaii. You will be our eyes in the field, passing the team members on the watch floor important information that describes weather events, associated hazards, and pinpointing the location of those hazards. As the Director of Operations, I am keenly aware of the modern technology our forecasters have at their disposal that provides weather observations across the Hawaii Islands that directly improves our forecasts, watches, and warnings. We use state-of-the-art equipment that includes Doppler radars, along with high-resolution satellite imagery every day, combined with advanced processors on the watch floor, to create a weather forecast that informs relevant watches and warnings. But even with this modern equipment, the forecaster's view of the physical environment around the state is still limited. We simply can't see everything. When you report on events that we cannot see, your information is vital to improving the accuracy, timeliness, and relevance of our watch and warning process. Your report may be the single report that directly leads issuing a warning on a weather event that threatens life and property around the state. You can make a difference. Welcome to the team. I look forward to working with all our Skywarn spotters around the state in the coming year. Good luck applying all of those new spotter skills. I hope we hear from you all soon. Better yet, see you out there in the field. Mahalo.